Welcome. In this video, we'll take a look at some more sinusoid graphs involving some vertical translations. So let's take a look at the first example. We have the function y is equal to 2 minus cosine 2x minus pi over 2. So it might be helpful here to rewrite this expression with a factored form here. So I'm going to write this above. This will be y. And I'm going to put the constant here, 2, to the back. So it's going to be our vertical translation here. So we have negative cosine. I'm going to factor out the 2, that b value that's inside the cosine. It'll have x minus pi over 4. And then we'll have a plus 2. So notice that this 2 here is positive. I'm just bringing that to the back of the equation. So let's take a look at each of these components and then we'll try to graph this in really 2 steps. So first, let's take a look at the amplitude. We know that the a value, we have the b value, this is the negative b over c. And then this is the d value. So let's consider each one. Our a value here first is -1, so therefore our amplitude, the absolute value of a, is equal to 1. The period is based on our b value, so the period p we can say is 2 pi over, my b value here is 2, so that'll be a period of pi units. And then finally our phase shift is going to be negative b over c, or negative c over b, excuse me. This would be negative c over b. This value here, so this will be a pi over 4. And so we're going to be shifting again to the right, pi over 4 units here. So I'm going to just put that on our graph here right away, pi over 4. That kind of tells us our starting point on this graph. And then the last thing we need to look at is the vertical shift. That's that d value on the back of the function now. That would be 2. So our vertical shift is going to be 2. In other words, our midline is now going to be the line y equals 2. So I have a new midline and I have an amplitude. So let's take a look at kind of putting together first the amplitude and the new midline that we have. So we'll take a look at both of those first. So I know I have an amplitude of 1. That's going to be helpful. And I have a new midline at y equals 2. So I'm going to just place kind of a dotted line here on my new midline. So y equals 2, we'll have 1 and 2. We'll call this 2 right here. And I'll just do a nice dotted line here to show where my new midline is going to be. And I'll put a value of 3. So notice that our graph here, since it's going to have an amplitude of 1, our graph is going to have a range from 1 up to 3. Since our midline is at 2, we're going to go 1 unit above and 1 unit below that midline. All right, the second thing we needed to think about is the phase shift and the period. Those kind of things go together when we're looking at that graph. So the period and the phase shift, we already have our phase shift pi over 4. And so I want to be able to make a full cycle of cosine in pi units. So I'm going to go and list out some more points here. I'll go 2 pi over 4, 3 pi over 4. Next one will be just pi. And then we'll have the next one is 5 pi over 4. So this interval here is pi units long. And so this is where we're going to draw our first cycle of cosine. And we'll notice here I've kind of divided this range, or really the domain here of pi of this cycle into 4 sections. And so that's going to mimic the shape of our cosine graph. Okay. One more note that we want to make here is cosine, usually, when I put as a cosine of 0, cosine of 0 is always equal to 1. And so we're always going to, in other words, start at our amplitude. So we want to start at our amplitude for our cosine function. One thing to be careful about here is that this is a negative cosine. And so when we have a negative cosine here, we want to start at -1 instead of +1. And for us, that would be at the minimum value, which we know is going to be 1. So I'm going to start at this minimum value of 1. And then I'm going to just rewrite this as a cosine curve with the pattern of cosine. So this would be back to our midline at 1/4 through. We'll be up at 3 at 3 pi fourths. Back down to our midline. And then back down to 1 by pi units. In this case, 5 pi over 4, which is where our shift would tell us. So my cosine graph here will have this shape. And in fact, we'll hit the value, the midline here at 0, 2 as well, if you wanted to fill that in. So again, a few key items that we want to remember about cosine is it always starts at its amplitude. And then again, we always want to divide that kind of period up into 4 sections. And that makes it helpful to graph with 4 points. So we'll take a look at one more graph with this translation added into it. Again, there's a few ways to do this, but one is just to, again, do as we have done in this example and just visualize where our graph is going to be based on the vertical shift and the amplitude. So we really have kind of 2 pairs of items, the midline and the amplitude, and then our period and phase shift. Those 2 pieces of information kind of work together as well. So let's take a look at a second example here, and this one will involve the sine function. So again, we see a lot of components here for the sine function. This is 3 plus 5 times sine of pi times x minus pi over 4. All right, so let's consider rearranging this as we did in our previous example. We'll have y is equal to 5 times sine. And then we'll factor out a pi here. So this will look a little bit different than before. We'll factor out a pi from this parenthesis and leave behind an x and a minus 4. Or a minus 1/4, excuse me. That would be a 1/4. And then I'm going to bring that 3 to the backside of this equation. All right, so I have a nice factored form here where I can identify all of my components. So let's try to walk through here and just fill in our table again before we try to approach the graph. So our amplitude A is going to be 5, so the absolute value of A is 5, so that's going to be our amplitude there. The period, again, is always going to be 2 pi divided by B. And so in this case, our B value is sitting right here. That is pi. So in this case, since B is pi, we're going to have a period of 2 units. So this is a little bit different than the ones that we've seen before. But again, a lot of times the period of some function is in maybe seconds for maybe a sound wave. And so it makes sense sometimes to not have pi in the period itself. So we have a period of 2, and then we have a phase shift. This is our phase shift right here, and that would be 1/4. Phase shift of 1/4. So we are shifting again here to the right, 1/4 unit. And remember that phase shift is always kind of the opposite sign that you think it will be there. So that negative 1/4 really shifts it to the right 1/4. And then again, we have a vertical shift here. That's the D value. And that would be 3, making the midline y equals 3. So our midline is shifted up 3 units. All right, so we've collected all of the information that's necessary for this problem. Now we just want to apply it with a sketch. So again, I'm going to start with the kind of combination of information with the amplitude and the midline. So I'm going to start with the midline. This is kind of like number 1. The midline is at 3. So I'm going to actually extend this graph just a little bit because I know we're going to need some more space. And I'll put 3 maybe right here. So this is my midline. It's not a great midline. Let's rewrite that. Maybe that's a little bit straighter. There we go. So there's my midline at 3. And now I'm going to take into account number 2, the amplitude. So off of this, I know my amplitude is going to be 5, and therefore I'm going to be a maximum of 5 plus this midline and a minimum of 3 minus that amplitude of 5. So 5 more than that would be up at, say, 8. We'll go about there. And then the minimum would be 5 lower or less than 3, and that would be down here at negative 2. So our graph here, since we have an amplitude of 5, our graph is going to be between negative 2 and 8. So that's the range of our sine function, negative 2 to 8. Okay, so now that we've taken care of those 2 pieces of information, now we're going to go to the phase shift. Where do we start my graph? So my starting point for my graph here is going to be at my phase shift. So we'll call this number 3. This is the third item we need to consider. We shift to the right 1/4 unit. And so we're going to put that 1/4 unit on our graph. We'll just call it right here. And then the last item that we want to consider is the period. And so when I look at the period, it's going to be 2 units. So that's kind of number 4 item. And I'm going to try to draw out this number line until I get really 2 1/4. So I can have a full cycle of the sine function on my x-axis. So on the x-axis here, we'll do a full cycle. And for this, we'll just go in halves. Because again, to think about where we want some points, during the period, I really want to have kind of 4 sections over this period. And so that would give me really 1/2. Every half unit, we want to go and put a point. So if you don't do this exactly this way, you still can get it, but this is kind of the best, I think, way to organize, to split that period up into 4 sections. And so every half unit, we should have maybe a marking. So let's do that. So every half unit will go a marking, so that would be 3/4. And I'll just do these in proper fractions just to kind of get us along here. The next marking, another half unit, adding a half would be 5/4. So we're really adding 2/4 every time. The next one would be at 7/4. And then we'll have one at 9/4. So these are really going to be working our graph 2 units to the right. And so over this 2-unit interval, we're going to have a full cycle of sine. So 1 cycle of sine on this interval. All right, so now that we have kind of our canvas set out for us now, we want to think about how do I actually sketch this sine curve. Again, we don't necessarily need to have a table at this point. We just need to work off of what this pattern of sine actually is. And so when I consider the sine function overall, the sine function, if I was to just say sine of 0 again, where sine is equal to 0, that would be 0. The sine of 0 is 0. So that means that when I start my sine function, I start at the midline. I always start my sine function at the midline. So we start our sine function at the midline, and this is a positive sine function, so I will start increasing. So let's take a look at this. I start at 1/4, and I'm starting at my midline. So there's my first point. And then I start increasing. So at 3/4, that would be at 9, or at 8. That's my maximum. Midway through at 5/4, I'll be back at my midline. I'll go down to my minimum at 7/4. And I'll be back at my midline through 2 units, which would be 9/4. So there's my kind of outline of my sine function. We'll finish it off by creating my curve. And there would be our sine curve. So just as a summary here, we started with just filling in our, really kind of writing our function in a factored form there. We filled in our table amplitude, period, phase shift, and our vertical shift. And then we went through kind of progression of charting our midline, setting our amplitude, getting our starting point with our phase shift, and then creating our endpoint with adding our period length. And then we're just sketching a regular sine curve over that range and domain. So hope this is helpful. you can obviously watch this through again and slow it down. Really encourage you guys to work through these problems as you just get better at working with the sines and cosine functions. We'll do some more graphs in our next video. Hope to see you there. Thanks for watching.